Hi, my name is Jeff Harrah. I'm Vice President of Solution Architects at Nasuni. And my topic today is to cover how we partner with our various cloud providers. Our mission here at Nasuni is, as it states here, we want to bring the simplicity, the durability, and the economics of object storage to our clients that we use. Historically, the problem is that applications that clients use don't speak in object APIs. Also, there's a challenge with the object storage being away from the premises where the work is being done. So our technology includes some components that we'll look at today to help alleviate those situations. So we're able to bring all those benefits of object storage to any enterprise that wants to be able to leverage them in terms of in the pursuit of modernizing their infrastructure. And this is where our life lives in my world, is making comparisons to other technologies. Now, we see a great market here, $14–15 billion in helping people modernize their digital business, and there's room for all of the vendors here we're talking about to actually partake in this market. And it's interesting when we go to market, whether it's us or some of our competitors like NetApp here, we work with the cloud services providers. And the trick of it is understanding that from our perspective, whether it's Nasuni plus Azure, Nasuni plus AWS, or Nasuni plus GCP, we're always being compared. And primarily, these are the three comparisons that we deal with in every integration, in every engagement we have. So Azure Files versus us, NetApp on AWS, which is some instantiation typically of Amazon FSX, or NetApp on MS, which is an instantiation of Azure NetApp Files. So the trick here is the use case, right? And how the infrastructure supports what the client wants to do. And this chart depicts where we live in terms of the use cases that we support and how we help people do things in their infrastructure. So there's a commonality between these charts, and that is the large middle of enterprise use case in file services. So pick your provider here. I'll talk about Amazon. On the left side of the chart, we're talking about fairly small enterprises, single location, small data footprint, use cases that support departments, et cetera, and without a high degree of capacity or sharing or synchronization need. Now, there's a huge middle area where we live and where we help Amazon address and help them be an enterprise file services platform using object storage, all the way to the other end of the spectrum here. And at that end of the spectrum, it's very much about transactions and ML and really churning data. That is not an area where we like to focus. In fact, NetApp, I'll speak about a competitor here, does a pretty good job of that. And we think that that's where their market exists. But all that area in the middle, whether it's files that are generated by people, whether it's files that are generated by machines, telemetric data, anything that needs to be captured where there's a lot of it, it's widely distributed, large files, and need for a lot of elasticity. So when we approach this, we think in terms of three words. One is scalable, one is simple, and the last one is there's savings associated with that. And it's worth noting as a cloud native platform, I think it's important for us to define how we are different from the historic architectures. And to talk about that, I'm going to bring up Russ Kennedy, our Chief Product Officer. He's going to take a moment to discuss this slide for you.
Yeah, thank you, Jeff. So really simple, what we look at is the whole spectrum of cloud services or file services that could be delivered to customers. And we put ourselves on the far right of that spectrum, if you will, in the cloud native arena, primarily because we are the only company that leverages object storage as part of our infrastructure. It's a key component of our infrastructure, and it delivers all of the services that we deliver on behalf of our customers. But you can start on the far left of the chart with your traditional on-premise hardware-based file platforms that exist in a lot of customer environments today. And as you progress slowly to the right, you see various versions of cloud becoming part of the infrastructure. It may be just simple cloud tiering, taking a copy of the data and tiering that copy into the cloud. It may be simple like moving or lifting and shifting technology from an on-prem deployment or architecture into the cloud so that it looks like it's cloud native, but it has the same limitations and restrictions that it had on-prem. You then also have some of the cloud service providers themselves building their own technology or leveraging existing technology that exists in the marketplace to deliver a cloud service, if you will. But again, some limitations, some restrictions, the need to have additional services like backup as part of the technology in order to meet the specific services and requirements that customers have. And then on the far right, with Nasuni, cloud native, object storage based, the ability to grow, scale as customers need to, but with edge devices that deliver the level of performance that customers need in order to access data, meet their application requirements, their SLAs, et cetera. We think that's the best approach for file data storage in the cloud, and it's been part of our core architecture from the beginning.
Well, at some point, as a former IT person that worked at an organization, you have to start talking about costs. And one of the comparisons we always get is, hey, Nasuni requires object storage. So we provide a software service that leverages a customer's tenant in one of the hyperscalers, their bucket. So that's two things, 1 + 1. If I'm looking at a first party service, how can that be more reasonable from a cost perspective? And what I would like everybody to think about is on the Windows file server side, the on-premises side, this depicts a 3-year deployment. Whoever's been through the machinations of re-architecting a solution and bringing something in and refreshing, et cetera, that cost even bumps up more. But there's a lot of stuff that's associated just with that deployment model. And in terms of file servers, you have to have backup, you have to have potentially WAN acceleration. So it's not a 1 + 1 for that particular area, but even that extends into the cloud services. So if I have something that's notionally a first-party service that's provided by Google or Amazon or Microsoft, there's a lot of attendant infrastructure to support that. Remember, NetApp still needs to be backed up. There needs to be associated file caching in any sort of remote location. There are tons of things that need to be considered. And we'll look at some of those with some real wins and proposed solutions that we've had for our clients now going forward. But the note on here is that while it may seem like a first party service is a one-stop shop, there's a lot of attendant cost and administration.
So is this total cost of ownership, or you've simply
total cost of ownership?
Okay. And I mean, is this with what you consider a typical workload, or do you have a specific workload in mind that you're basing this on?
This is generally applicable. It's less about the workload itself. It's the capacity and the associated infrastructure to support that. But
the way a workload uses the capacity changes how much delta there is.
Indeed. So yes, and so from a capacity standpoint, we'll assume that that's equal across all. We do have the ability to apply storage efficiency in the object store. So, but I'll set that aside for now. But we're talking the same capacity use case across here. The difference is in the attendant infrastructure that's associated with it. Like I stated earlier, in terms of data protection, backup systems, additional costs for additional storage that's used to support like snapshotting and other things like that. That make sense?
Well, I think you're missing the point of my question, which is that the way that you actually use your 100 terabytes wildly varies on how much how much delta information you need to store in it, and how much needs to be backed up on it.
True. Yes, so I think I understand the question in terms of the comparison here. We're talking just capacity to capacity. Our license cost, how much it would cost to acquire Nasuni over a 3-year period compared to those other items. The difference is in how they use the back-end capacity in certain cases. So if the front-end use case is identical for all of us in terms of this comparison, but how we address the backend capacity in terms of unlimited snapshots, which alleviates the requirement to have backup infrastructure.
But my understanding is that Nasuni was not the backend store, right?
No.
So my viewpoint of this, wouldn't it be the Nasuni column there that we have on top of one of these others?
No, these others are competitive offerings. So if you look at NetApp Cloud Volumes ONTAP, CVO notionally, the service that it provides the same service as our offering, but they have tiers. They have more expensive backend storage for their warm and hot layers. They have tiering down to cold layers, where in our world we just have one because of the way we cache. So that the difference here isn't exactly like you say. It's how the backend storage, which is in the customer's tenant, so they pay for it. Mm-hmm. This is including our software in and the tenant is included in this conversation here as well, because we compare. Look, if I'm paying for an S3 as a client, if I'm paying for an S3 bucket and I'm buying it from one of my folks over here, or if I'm buying it from one of my folks over here, that cost is the same. It's how you treat that and support that data on the back end. That make sense?
I see where you're trying to go with it, but I'm not necessarily sure I agree with it.
Okay.
Because I mean, Nasuni has a certain cost associated with it, and then there's going to be your own infrastructure that you might be storing some things on that's going to have some cost associated with it, and then there's going to be the stuff that you've put in clouds, which, as I said, might be a variety of different sizes. Okay,
I have pictures that we can talk about. Is that fair enough? But first, why do people go ahead and consider making these changes? They want to consolidate their workloads. They want to get the cost efficiency that's associated with that, get out of the data center, access cloud services, as we help people with our analytics connector. Look, if you've got all your data in the cloud service providers have great capabilities for analyzing that data. It's already there. Why not use it? And the holy grail of being able to move from managing blinking, spinning devices in a data center and moving toward managing services to help a business move forward is important. Also, hey, every use case is becoming distributed at one level or another. And what becomes important there is synchronizing files. So having a single image of the file that everybody accesses that can be accelerated to different locations, and can also be locked, as if I'm in Perth, Australia, and somebody else is in Singapore looking at the same document. They can make sure that we enforce a lock over it. One of our most important features and functionalities is in terms of data protection. I'll talk a lot about this today, but since we have an unlimited amount of immutable snapshots, we get all the benefit of the restore capability of a typical normal backup system without any of the associated infrastructures. So in situations where I have to recover a file from yesterday or 2 years ago, the time to recover that is identical because it's just a pointer system-based backup. The nature of object store is that it's immutable, which means that I don't have a situation where something is changed. As I create a file, I create a set of objects that are associated with it, chunks. And as I modify that file, I create a wholly separate new series of chunks. And with all that combined together, it gives us a super strong ransomware recovery story. So consider this. We have a person that puts together infographics for us, and he has a great depiction of a clock with down to 37 seconds. Now, that's how long it takes us in our demonstration to recover 1 million files. And part of that infographic is how many things that you do on a daily basis that take more than 37 seconds. My personal favorite is eating an apple. You can recover your 1 million files, and that's important. Look, the reason people...
I just want to make a comment because y'all keep saying that, and it's great that you can recover the files themselves that quickly, but there's so much that goes on to restoring and recovering from ransomware. So you're recovering the files. Mm-hmm. Then there has to be, especially in any organization that's even medium-sized organization, there has to be some kind of data government that checks out okay, are these the right files?
Yep.
Have these files have we stopped the attack, number one? Have we got a clean place to restore this to? All of these things are these the files that we can recover that we won't reintroduce the infection? So it's like a whole bunch has to go on. So it's not
You're exactly
under a
right.
minute. So it's not really, that's great that you're recovering the files themselves, but which files have you recovered? Have you recovered the right files? Have you got a place to put them?
Mhm.
And that all is another whole thing that happens.
Yes. So I don't have a demonstration of that. And so primarily as a user, what I would be interested in is where did it come from first? Where did it come from? How can I stop it? And then which files were affected so I can recover quickly. Right now we have in a real world example, bringing back 100 plus terabytes of data took an hour to do the where are the files and recover them. So as the product is delivered today, it is a process where we can look through logs and see where things were which have been affected to make that recovery. Now, when we recover, we don't move anything. It's already there. We just repoint to it. So that's one area that alleviates one thing that you discussed. But our goal and our direction is to have the ability to support those other components that are out there. And I know there's work being done, but it's not a roadmapped item right now to be able to address that. And the key is too, when compared with a typical snapshot arrangement, if you're going to snap a lot, you run out of there's a limit that you run into. And I've got clients with over 1 million snapshots. And would you ever need 1 million snapshots? Who knows? If you take a snapshot every minute, you could run into 1 million snapshots in months. And ransomware, as we know, is patient, right? So it's going to wait around until it gets you to make sure that your backups are the only thing that you can get. And believe me, it's a lot easier to go to point to a file or a file system or an image, a version, than to go back and pull something off of a tape from a father-son rotation last month. So it's much more granular. Is it completely automated? Perfect world is you've got a problem. I stop that user, say yes or no, or give me the opportunity systematically as Nasuni to say, I'm going to recover this for you. Definitely, that would be, I think that's something more about what you're asking about.
I don't think what I'm trying to say, I'm not asking, so what
Okay.
I'm trying to say is that's never going to happen. There's always going to be, it's not going to be as automated as people would like it, or if it's not, it all depends on what the situation is, but it's not going to be under a minute when you go from being attacked and knowing it to having the files up and running and usable by a user.
Agreed.
Right.
Yeah, if you make the decision in 37 seconds, you've probably made the wrong decision.
No argument there. But in terms of recovering it there. So let's talk about what this looks like. And I hope this will answer the question that you had earlier. So this is a pharmaceutical company. It's a win. And their focus was on eliminating the costs associated with third-party backup tools, reducing the hardware management, and eliminating the complexity. This pretty common pain points that we see are multiple Windows file servers and across multiple sites, excessive backup and DR costs that are associated with having that instantiated at every location. And we were compared, in this case, we were working with Amazon, so we were compared with AWS S3 File Gateway. So notionally, what File Gateway does is it sits on premises and allows people on premises to access their objects in the cloud. So we won. The reason that we won is we had a single solution that can leverage the object store in a very simple way and also provide for the edge access requirements. And we eliminated the backup too. So what does that picture look like with us? It's a 1 petabyte deployment, 50 offices. And as you'll see on the graphic depicted here, there's a single bucket that we talk to. UniFS, our file system, lays on top of that bucket. It includes the data, the metadata, information about the edge appliances. Now, the edge appliances depicted at the bottom of the picture are where we back up, or not where we back up, but where we access the file. So an application or a user at a location, a physical location, can access these virtual edge appliances, and that does the translation into the object store. That can also be instantiated in the cloud here in a virtual instance. depending on the users. So if you have remote users or a smaller office that doesn't have a virtual infrastructure to put our VM on, we leverage that tool. So, and I just want to illustrate one thing. When we're looking at saving against the other solutions, this is what I'm talking about here. If I'm looking at an AWS gateway, there are a lot of considerations in terms of the tool and how it is applied in this particular area here. The trick here is that each of these gateways have to talk to their own bucket. So the difference is there are 50 buckets up here in these 50 locations. And then on top of that, there are 50 management consoles that you have to deal with because each of those instantiations for a bucket has its own management console. So there's attendant administrative friction and costs that's associated with that. So irrespective of the data that's coming in from the bottom, it's how it's used and how it's accessed on the back end for total cost of ownership. And in this instance here, there aren't snapshots other than the S3 versioning. And so there's no single point to be able to access that. When you think about it, there's no single point to be able to access the data and share it across areas at the cloud side. So that means there has to be some peer-to-peer talking, which could include some WAN acceleration depending on the use case. There's a lot of complexity that's built into it. So when you talk about the total cost of ownership, this is the primary difference. It's all about the infrastructure. And that should be driven about what the use case is. If I had one location that I needed to do with this, that would be reasonable. But this many locations, it causes some consternation for our clients. Another example here, this is a global engine manufacturer. I think they had eight sites, if I'm remembering, and they wanted to consolidate their engineering drawings and design data. Also, across these 8 data centers, there was a difference in management, and they have this distributed environment, and they don't want to spend a ton of money building out infrastructure on the edge. Now, again, our edge appliances download as many as a client wants. We don't charge for those individually. They just come as part of the license. And they had a great initiative here to migrate over a period of 2 years. They couldn't share the files. Cost management was difficult for them. Security and protection, and obviously data silos were the pain points that they were trying to eliminate in this 8 location deployment. And so they looked at a number of different things: AWS S3 plus Nasuni, as well as AWS FSX for NetApp ONTAP. And this is an interesting one. It's a 10 petabyte deployment, and not all of our deployments start at huge petabyte numbers. We'll talk about that a little bit later. But they were very interested in this case in the fast file restore and ransomware mitigation. So here's what our deployment looked like. Here's a spoiler alert. All of our deployments look very similar because we all use an object store in the cloud, and we all use, every one of them uses some sort of edge appliance, whether that's a virtualized system on a hypervisor, could be instantiated in the cloud. And the thing about this one here is that one of the key differences is we don't have to tier. We don't have scalability limits with how we put data into a particular bucket. And that'll be illustrated next. So if you're looking to compare this with AWS FSX, now remember, as I discussed earlier, FSX does good things in really fast transactional world, but they do not scale to that large middle where we help people very well. And this is evidenced by some limits that are associated. So if you have a 10 petabyte deployment like these folks do, and you have 2 petabytes worth of hot data that you need to address, in terms of FSX, you have to limit you have a limit of 192 terabytes for that fast data volume. And then everything gets tiered down to the capacity layer. So to accommodate that with FSX, you need 11 distinct instantiations in the cloud, where again, ours is just one. And since we're able to access the S3 infrequently accessed here, we have a performance capability associated with our caching, and that tier to be able to accommodate it with one tier worth of object store, whereas the capacity tier is the only object store in this deployment. So again, one instantiation versus 11 in this case. Not only that, they needed edge caching. So there's a cost associated with a NetApp file cache tool, global file cache tool. There's an administrative cost associated with it. Look at it needs Windows, it needs all the CALs, everything associated with that. And it needs to have management through a number of different core servers. And technically, if you want to have a DR in this scenario, you need to have another identically instantiated cloud deployment or on-premises deployment of the 11 instances that you have. That's the way NetApp works with SnapMirror. So when we talk about why it's so much more expensive for a given use case to consider this infrastructure, it's because this infrastructure wasn't built to be cloud native forever. We have an unfair advantage. That was why we built our software. Whereas this is adapting something to live in the cloud that is not specifically designed for the cloud.
Well, I'm sorry, but I mean, I'd like to kind of, call out that slide because, I mean, at least in my opinion, you're comparing here peers to bananas or something like that. FSX for NetApp ONTAP is not a tool that I would be considering if I wanted to deploy a distributed file storage solution.
Yes.
So I have the feeling that here you're comparing yourselves to the wrong vendors. I mean, no offense, but
you can't offend me.
FSX for NetApp ONTAP. If you have someone who's trying to use FSX for NetApp ONTAP to do a distributed cloud storage solution, it feels like they're maybe out of their heads or doing something wrong. I mean, it's inherently a cloud file system, right? So you would want to have that to be adjacent to your cloud workloads, but not to use that for a collaboration solution.
Let me say that two things. You can't offend me. I can't have my feelings hurt. It's just how I'm wired. And you are so right. I didn't make this comparison. The global engine manufacturer actually made this comparison for us. So it's one of the top 3 comparisons that we get is when people come in and they start to ask about, hey, what else should we look at? That this is the one that we competed with. Well, it's easy for me to say because I do work for Nasuni. I would prefer everybody not to look at this solution. Keep FSX, like you say, what it's really good at, and then look at us because we can help in this great use case that we've got going on right now. So I totally agree with you.
Really, just want to finish that point. It's not really a kind of. It's more the way in being educating the users, your customers, your prospects about the strong points of your solution versus the others.
Yes.
Yeah, and Max, it's a great question. If I could just add to what Jeff said, the reason why we are compared to the NetApp solution in the cloud is because this customer had NetApp on-prem. That was their starting point. They started with a NetApp infrastructure in their 8 data centers. And when they looked to how can I move this solution to the cloud, the NetApp answer is to go with FSX for ONTAP. That's their comparison or their solution. We love that because of the limitations that Jeff pointed out in terms of scalability, manageability, extra cost associated with it. You're absolutely right. It might not be the use case necessary to solve the problem, but that's the starting point that the customer had. And so they're comparing us to the NetApp answer from a cloud perspective.
Well, yeah, and it's a good point, and it's a fair point, and that's where I think the context is important there, because it felt like if it was something which was being built, out of the blue, on purpose on the cloud, and then that makes sense.
No, exactly. And by the way, the reciprocal of that is true. If somebody brings us a use case that's not in our wheelhouse, I don't want to talk to them about it. I'll say you need to find something else to do with this, right? So.
I was simply going to say that, a big part of that is because NetApp is going to come in with their ONTAP classes on the entire time.
Yes, of course.
That you, of course, want ONTAP.
Sure.
Totally correct. Thanks for the question, Max. And then this is a proposed solution right now that we'll review quickly. They're also interested in getting on the pathway to maximize their protection in a ransomware attack. But they also want to standardize their backup in DR. All of these are loosely associated. The pain point is they do have 5 to 10 petabytes of data that they want to address, and it's costly for them right now, and they have a number of locations. So our proposal for them is obviously NetApp plus Azure Blob, and we're being compared with Azure Files, NetApp CVO, and CVS. So why we think this is a good idea is that we can provide simplicity at scale and also address some of their concerns around security. So here's our NetApp or Nasuni and Azure Blob proposed solution. It's 950 terabytes to start. Remember, this is a 5 to 10 petabyte deployment. So they're looking to grow into it. Again, spoiler alert, we have UniFS on top of the Azure Blob. It takes the data, the metadata, information about the state of the edge of appliances. We cache data locally. We send that data up to the cloud in a series of immutable, unlimited snapshots. And when you start looking at Azure Files from an equivalent perspective, which is what they're looking at now, there are some challenges associated with this. And again, this is their, to Max's earlier question or comment, they are coming to us with this. So we talk to them about how this is deployed. Look, if you have 1, 2 system or locations, it's likely a reasonable situation. But think about it this way. There's a file limit on Azure Files of 100 terabytes. So if you have 950 terabytes, the easy math is you need 10 of those. But it's not only about that, it's about how you access things from the remote sites, because you have to have physical infrastructure. So the concept here is I put everything into the cloud and I get rid of my local instantiated Windows file servers. But to get it at a performance requirement that I need for my users and applications, I have to reinstantiate all my physical infrastructure on the premises side. So the issue there is that, well, it solves one issue. You have things in the cloud, which is good, but it doesn't alleviate any of the cost. And associated with this too, you have to have Azure backup to back up that information because there's no snapshot console. All right, so there are a 200 snapshot limitation here, but as we discussed earlier, that ransomware is patient. That's not going to help you out. So you got to address it with a backup, which they do. So there's complexity. Again, we would love people just to recognize out of the box that, hey, it's a great idea, but it doesn't fit for us. But we end up having these comparisons, which is illustrating that is the purpose of this conversation. And I said earlier that not all of our clients start with a huge data. In fact, the vast majority of our clients start with a smaller data footprint. And this sort of shoots and ladders approach talks about a real customer situation where they started with a very small, I think it was 15 or 20 terabytes here in a single location. They started to add more locations. They ran into a challenge. They just had to acquire a bunch of different spots, or there's an allocation and supply chain issue that they have to address. If NetApp can't get stuff, we can. Well, Amazon can, or Azure can, or Google can. They have the line on that. So we help them move through that process of growth and addressing some of the issues. And they're at 1.2, 1.3 petabytes at this point, and that's really common for us. You know, we have really happy customers, and they grow with us, and this is where the vast majority of them start.
I really wanted to bring up something that just happened a couple of weeks ago. A customer came to us and they said, "We're worried about ransomware. We're worried about what we would do if ransomware hit. Can you help us?" And we said, "Absolutely. Like, tell us how we can help." They're like, "Well, we want to run through a scenario." So we said, "Great. We've got a script. We can replicate it. We set up the environment for it." And so we brought in the customer service person who's handled the most ransomware calls at Nasuni. And in prepping for it, she said to me something I thought was really interesting. A couple of things. One is she said, "Look, half my job when people call in is calming them down. You know, half my job is like everyone's freaking out and I just have to be the voice of reason that says this is what we have to do next and whatnot." The other thing she said that I thought was really interesting, and this might be you might all know this already, I didn't know this. She said every one of these attacks happens where they get root access to AD. Mm-hmm. And so she said the biggest problem is all of a sudden, you know, the attacker is going wild because they can control anything in the environment. She said, but what's helpful is we've got the logs from AD that will tell you this is where it started. So she's got this playbook now where she's like, okay, I think I've seen this before. Everyone's freaking out. Let's go check the AD logs. We get to the AD logs. And the point I wanted to make about that was not that that's easy to do that part, but when we then say, let's go to this point in time. And the minute that we start that process and we restore it to the time where it's available, especially if you're talking about like most of our customers have the starter appliance, the main appliance in one place. If you start the restore there, it does take this kind of 36 seconds to be able to restore, you know, a bunch of stuff under most conditions. There are some exceptions to that. As soon as that little process like finishes on the Nasuni management console, the next thing they do is they say, customers, just start hitting the volume and see what you can find here. So the only reason why I wanted to challenge that was because you're absolutely right. That whole process is chaotic and crazy. But once we actually start the restore, which for almost any other technology, I know any other technology out there, the restore process is not like, you know, pick spot, hit button, wait, you know, grab coffee, eat apple, you know, and then you've got the files available. But it really is, customers can start hitting at that point.
Mm-hmm.
The other thing I would say is we found out about a couple of years ago that one of the major hotel chains, which has been a customer of ours, has been hit by ransomware like every week. And the thing that was surprising to us is they never called us.
Okay.
And so when you have Nasuni, you really do have a different approach to how you're doing this and a different way of thinking about it. If you miss the restore point and you get it again, you go back again to the other restore point. So I just really want to get that message out there because it is a really different model.